Today, every living person belongs to one human lineage, Homo sapiens. But for most of the history of our genus, Earth was home to several kinds of humans. Some were separated by continents. Others lived close enough to meet, compete, exchange knowledge, and have children together. The mystery is not that they once existed. The mystery is why every other lineage disappeared as a distinct population, while ours alone continued to spread across the planet. That question is harder than it sounds because there was no single extinction day. Homo habilis vanished long before Neanderthals. Homo erectus survived for more than 1 million years before its last known populations disappeared. Island humans followed different ecological paths. Denisovans are known mostly through DNA. To explain why Homo sapiens survived, we must examine many endings, not force every human lineage into one dramatic final battle that archaeology has never actually revealed anywhere. Homo habilis is often introduced as one of the earliest members of our genus. It had a larger brain than many earlier hominins and is associated with simple stone tools, although the exact maker of every tool remains uncertain. Its importance is not that it marched directly toward us. It shows that the human family was already branching, experimenting with different bodies and behaviors, and losing lineages long before Homo sapiens appeared on Earth itself. Then came Homo erectus, one of the most successful humans ever to live. Populations linked to this lineage spread far beyond Africa, endured changing climates, and used increasingly sophisticated tools. Some may also have controlled fire. Homo erectus lasted far longer than Homo sapiens has existed so far. Yet even extraordinary longevity did not guarantee survival. A lineage can thrive for immense spans of time and still disappear when environments, populations, and opportunities change together. Homo heidelbergensis represents a more complicated chapter. The name is applied to fossils from the Middle Pleistocene that may sit near the ancestry of Neanderthals, Denisovans, Homo sapiens, or several regional groups. Scientists disagree about which fossils belong together and whether the label is too broad. That uncertainty matters. Human evolution was not a clean ladder of replacement. It was a tangled population history whose branches sometimes separated, reconnected, or remain difficult to name today. Neanderthals were not failed versions of modern humans. They survived across Ice Age Eurasia for hundreds of thousands of years, made complex stone tools, controlled fire, hunted cooperatively, and adapted to difficult environments. Some used pigments, ornaments, adhesives, and carefully prepared living spaces. Their brains were not simply smaller than ours, and their behavior was not primitive. Any explanation for their disappearance must begin by recognizing how capable and resilient they actually were in practice. Denisovans are even harder to picture. Scientists first recognized them mainly through ancient DNA, later connected to a small number of fossils from widely separated parts of Asia. Their genetic legacy suggests that Denisovan-related populations occupied diverse environments and mixed with ancestors of some people living today. But their faces, cultures, and final centuries remain poorly known. Their story warns us that disappearance in the fossil record can reflect missing evidence as much as extinction. On the island of Flores lived Homo floresiensis, a small-bodied human with a unique combination of ancient and derived features. Its survival into the late Pleistocene shows how isolation can produce an evolutionary path, unlike anything on a continent. Stone tools persisted there for a long time, yet the disappearance remains uncertain. Changing water supplies, ecological stress, volcanic activity, or the arrival of other humans may have mattered, but no single cause has been proved. Homo luzonensis adds another fragment to the puzzle. A small collection of teeth and bones from Calao Cave in the Philippines revealed a human lineage with an unusual mixture of traits. We know too little to reconstruct its population size, technology, diet, or extinction. That absence of information is important. The human past almost certainly contained lineages we have not discovered, and some vanished without leaving enough evidence for a confident explanation from science today. Homo sapiens emerged in Africa roughly 300,000 years ago, but our appearance did not immediately empty the world of other humans. For most of our early history, we were one lineage among several. Some sapiens populations expanded and survived. Others disappeared without descendants. Our eventual success was not guaranteed by our species name. The question is what allowed enough connected populations to persist, recover, and keep expanding when other lineages could not continue. One popular answer says Homo sapiens survived because we were smarter. The evidence does not support such a simple ranking. Neanderthals had large brains, complex technologies, and deep environmental knowledge. Brain size alone cannot measure creativity, language, foresight, or cooperation. Archaeological differences can also reflect population size and contact, not individual intelligence. The decisive advantage may have come less from a superior mind inside one skull than from more minds remaining connected across a landscape. Extinction happens to populations, not abstract abilities. A group can contain skilled hunters, expert toolmakers, and intelligent children yet still fail if too few people remain. One accident can remove several adults. One harsh season can reduce births. A shortage of partners can intensify inbreeding. A disease can strike a settlement already isolated from neighbors. When numbers stay low for generations, resilience weakens, even if every surviving individual is highly capable and behaviorally flexible too. Small communities also risk losing knowledge. Imagine that only 2 people know where to find a rare stone, prepare an adhesive, or treat a dangerous wound. If they die before teaching others, the technique may vanish locally. In a larger network, the same knowledge exists in many minds and can return through visitors or marriage partners. Cultural survival therefore depends not only on invention, but on enough people copying, carrying, and renewing what was learned. Ancient DNA from some Neanderthal sites reveals close relatives living together and evidence of limited local breeding populations. At Chagirskaya Cave, genetic relationships suggest a small community, with women moving between groups. That picture fits demographic vulnerability, but it cannot represent every Neanderthal everywhere. Other sites show movement, exchange, and changing connections. The careful conclusion is that some Neanderthal communities were small and exposed to risk, not that all were permanently isolated from one another. Early Homo sapiens groups were not automatically large or successful. Genetic evidence from some of the earliest modern humans in Europe points to tiny populations that left few or no descendants. What may have mattered was repeated movement from other regions. New arrivals could replace losses, bring partners, and restore connections. A single group might fail, while the wider population continued sending people into the same landscape. Survival belonged to the network, not every camp. Archaeologists sometimes find stones, shells, pigments, or ornaments far from their natural sources. Such objects suggest that people moved materials across long distances, whether through travel, exchange, or chains of neighboring groups. These routes were more than trade lines. They could carry news about water, animal migrations, weather, and danger. They also connected potential partners. When one valley suffered, people linked to other communities had more options than a group facing crisis alone without help. A wide network turns culture into a backup system. If one band loses a toolmaking tradition, another band may preserve it. If local prey disappears, visitors may know different foods or routes. If a community becomes too small, marriage links can restore genetic diversity. None of these advantages requires every Homo sapiens individual to be smarter. They emerge from repeated contact among people. Connectivity makes information, resources, and relationships harder for one disaster to erase. Technology may still have shifted the balance in particular places. Projectile weapons could reduce the danger of hunting. Needles and fitted clothing could help in cold. Specialized tools could open new food sources, while ornaments may have signaled identity across distant groups. But no single invention appears everywhere at the moment other humans vanished. Technology worked through demography, and innovation mattered most when enough people shared it, maintained it, and adapted it to problems. Food flexibility is another proposed advantage, but the stereotype is misleading. Neanderthals often hunted large animals, yet evidence also shows use of plants, small game, birds, shellfish, and other resources in some regions. Homo sapiens likewise followed different diets in different environments. The meaningful difference may not have been one universal menu. It may have been how quickly a population could combine local knowledge, imported ideas, and new tools when familiar resources declined or vanished. Adaptability is not a magical trait carried by one species. It is a process. A group notices change, experiments, remembers what works, and teaches others. Larger or better connected populations can run more experiments and preserve more solutions. Homo sapiens may have benefited because information moved across networks and across generations. When coastlines, forests, or prey changed, some communities already had contacts, tools, or traditions that made a different strategy possible. before the crisis fully arrived. Climate placed repeated pressure on every human lineage. In Eurasia, rapid shifts altered forests, grasslands, water, and animal populations. Habitable zones expanded, contracted, and sometimes broke into isolated refuges. Small Neanderthal populations may have become harder to reconnect after each disruption. Yet climate alone cannot be the answer, because Neanderthals survived many earlier cold and unstable periods. The final decline likely occurred when environmental stress combined with demographic weakness and the arrival of expanding competitors. Floors may have followed a different path. Island populations face special dangers because their territory and water sources are limited. Evidence suggests severe drought affected the region near the end of Homo floresiensis at Liang Bua. Ecological stress could have reduced food and freshwater, while volcanic events or arriving humans may also have changed conditions. The uncertainty matters. Homo sapiens did not necessarily eliminate every lineage through the same mechanism, or even through direct contact. For Homo luzonensis, the honest answer is that evidence remains too sparse. A few bones and teeth can reveal anatomy and age, but not the final structure of a population or the event that ended it. We do not know whether climate isolation, competition, disease, or simple demographic chance mattered most. This gap is not a failure of the story. It is evidence that some human disappearances occurred beyond the resolution of archaeology available today. When Homo sapiens entered Europe, Neanderthals did not vanish immediately. The two lineages overlapped for thousands of years, creating time for observation, avoidance, exchange, competition, and interbreeding. Encounters probably differed from place to place. Some may have been hostile. Others may have involved shared landscapes or individual movement between communities. A long overlap makes a single conquest story unlikely. Replacement was a process unfolding across generations, not a single final battle between opposing armies anywhere. Competition can still matter without organized warfare. Two populations hunting similar animals, gathering the same plants, or needing the same shelters can affect one another simply by being present. If one population is larger or repeatedly reinforced by newcomers, small advantages accumulate. A local Neanderthal group may lose access to prey or partners without ever fighting a dramatic war. Repeated pressure can be decisive when numbers are already low and recovery is slow for generations. Ancient DNA proves that these encounters were not only competitive. Some early Homo sapiens individuals had Neanderthal ancestors only a few generations earlier. That means people crossed social and biological boundaries, often enough to leave descendants. Interbreeding did not save Neanderthals as a separate population, but it changed what extinction meant. As small groups were absorbed into expanding sapiens communities, their genes could survive even while their distinct population identity gradually disappeared from the landscape. Denisovan ancestry tells a similar, but less complete story across Asia. Different modern populations carry Denisovan-related DNA, especially in parts of Oceania and Asia, showing that multiple encounters occurred. Some inherited variants later helped people adapt to local environments, including high altitude. Denisovans therefore did not disappear without trace. Their populations ceased to exist as recognizable independent groups, but portions of their biological history continued inside the expanding and increasingly mixed populations of Homo sapiens. Population models show how replacement can occur without assuming a dramatic biological superiority. If one lineage is more numerous, receives repeated migrants, and sometimes absorbs members of the smaller lineage, the imbalance grows over time. Each generation shifts the proportions slightly. Eventually, the smaller population may no longer reproduce as a separate community. This process can look sudden in the archaeological record, even though it unfolded through countless ordinary births, deaths, movements, and relationships instead. Chance must also remain in the explanation. A storm, drought, epidemic, failed migration, or unlucky sequence of deaths can redirect a small population. The same event barely noticed by a large network may destroy an isolated group. Homo sapiens also passed through bottlenecks and local extinctions. We are here because enough populations survived at the right times, found partners, reached new habitats, and recovered from losses. Survival was contingent, not guaranteed by intelligence or destiny. Homo sapiens did not survive because every other human was weaker, less intelligent, or doomed. Different lineages disappeared for different reasons. Climate narrowed habitats. Small populations lost resilience. Networks protected knowledge. Migration restored numbers. Competition added pressure. Interbreeding absorbed people and genes. Chance altered every outcome. We are the last surviving Homo lineage, but we are not untouched by the others. Parts of Neanderthals and Denisovans still travel with humanity wherever it goes across Earth.